Okay, in this video we're going to go through the 7.3 activities. So there are two main activities. One is similar triangles that are formed when you drop an altitude in a right triangle. And the second topic is the geometric mean concept. Okay, so doing this first problem, what I did was I did this entire problem. And I'm going to walk through how I did it and tie in the color with it. Okay, so first off it says, when the altitude AV, so let's get a color for the altitude. Okay, so the altitude is AV, this is AV on our triangle. So when the altitude AV is drawn to the triangle ABC, two new triangles are formed inside the large one. Okay, so I colored one in orange and the other one in green, and the big one I kind of outlined in purple. So then I asked you to state the similarity relationships. So looking at the large triangle and naming that ABC and starting at the right angle, okay, so this was a right angle right here at A. Look at the orange triangle. So that is the top small triangle. Start that name where you have the right angle. That's at V. So A and V have to be equal because they are both right angles. Okay, what other angle has to be equaled? Well, they both share angle B. So those angles have to be equal. If two of the angles in a triangle are equal, then we know because a triangle has 180 degrees that the remaining angle must be equal. And that's the order that you want to present your answer to show you have similarity. Okay, angle A equals angle V, angle B equals angle B, and angle C equals angle A. Okay, then we're going to move on, and we want to tie the large triangle to the bottom small triangle. So that's the green outlined triangle. So again, I'm naming the large triangle ABC. Be consistent with that. I started naming the triangle with the right angle. So let me change color here. Okay, so the right angle is A. The right angle in the green triangle is V. So that's why they are both the front angles in our naming of the triangles. So then look and see how they have the angle C right here in common. So C has to be in the same spot. Okay, the other angle that has to come along for the ride is the A angle, and it goes in the middle. So that's our similarity statement. Triangle ABC is similar to the small green triangle VAC. So angle A equals angle V, angle B equals angle A, and angle C equals angle C. So they're similar. Okay, so then once you've gone through that thought process, if you want to relate the top, which is the orange triangle, to the bottom, which is the green triangle, use the exact same wording. Okay, that is this, and this order goes here. They are similar. Okay, so stop the video and go back if you need to listen to that again. But we're going to go on to the next page where I have your turn. Okay, so here's your turn. So look and see what you have. I started naming the large triangle this time with F. So here's where F is. And here is your D is your right angle. And then E. So I say large triangle to the left small triangle. So the left small triangle is this triangle that I've just colored in orange. Okay, so the left small triangle is the orange one. So what are you going to do in terms of letters? So go ahead and do that now. Tell me what the letters are, and I will come and do it as well. But I want you to think of an answer first. Okay, so hopefully you got an answer. So this is how I'm going to set it up. I see that I need to have 3 letters. I see that D is a right angle in my original big triangle. I know that G is a right angle, so I'm going to put G in the middle so it matches the D in the middle. Then I look at that small triangle and I see that F is in common. So I'm going to put F where the F is in the big triangle. Then to finish naming it, I have to grab the D. So that's my order. Okay, we're going to do the next one. So go ahead and think that through. You can stop the video and then you can look and see what I've done. Okay, so I'm going to color this in with some green so I know where we're looking. So the large triangle is still FDE. I need 3 letters for the small right triangle, or the small triangle to the right. Okay, so I know that D is the right angle in the big triangle, and I know that G is the right angle in the small triangle. I can see they have angle E in common, so I'm going to put E in the same spot, and then the other angle that comes along for the ride is the D. So that is the green triangle. That's the order that identifies the similarity with the larger triangle. Okay, so now go ahead and do your left small triangle to right small triangle using the work you've already done. So you should be writing things in, but you can check your work against mine. Okay, so let's go on to the next page. Okay, this next page talks about geometric means. So all of the red, so let me just circle those for you. All of the red act as geometric means. So they are geometric means to different parts of the hypotenuse. And the hypotenuse refers to the hypotenuse of the big triangle. My apologies, my dog just saw a squirrel at the window. Okay, so where were we? Okay, we're going to do the X first, and we're doing that in blue. So here is the X. It is the geometric mean. It's a leg. It's the geometric mean between the side of the hypotenuse closest to that leg, so that's the 20, and the entire hypotenuse. So the mean position is always going to be the bottom of the first fraction and the top of the second fraction. Do your cross products. You will get x squared equals 900. Take the square root. That will be 30, and you have identified the geometric mean, and you found the length of that side of the original big triangle. So let's move on to the y. Okay, when doing the y is the altitude, okay? So it has another name. It's not a leg, it's an altitude. Okay, so I have everything labeled for us now. And what's happening here is that altitude is the geometric mean between each of the parts of the hypotenuse. So I have 20 and I have 25 there. Okay, so do your cross products. You should be getting y squared is 500. And then what I had here was 5 times 10 times 10. And then I grabbed out a 10 and brought it to the front as a single, and that's how I got 10 root 5. Okay, that brings us to z. Z is also a geometric mean. It's the geometric mean between the sides, so here's z, between the side of the hypotenuse closest to that leg and the entire hypotenuse. So that's why I have 25 and 45 located here and here, and my means always go there. Do your cross products. Z squared equals 1125, and what I realized was I had 5 times 15 times 15, because that was 225, and that came out as a single, and that's how I got 15 root 5. Okay, so you can go back and play that again, because there's a lot of steps here. I'm going to go on to the next page. Okay, so in this next page, this is your turn. So I kept the same colors just to be consistent, so you can go back and look. All the red are functioning as geometric means, so you should be filling in what you need. So I'm going to ask you to turn off the video, see if you can fill yours in, and then listen to what I've done, make sure it makes sense. So here we go. Okay, so x is the geometric mean. Here's my x between the piece of the hypotenuse closest to it and the entire hypotenuse, which is 14. So 2 times 14 is 28, and then 28, you've got to figure that out. What's that going to be? Well, 28 is 4 times 7, but 4 is 2 times 2 times 7, so I can bring that out as a single, and I have 2 root 7, and that's my value for x, which is a leg of the original triangle. Okay, time to turn to green. If you haven't tried to do this first on your own, please do that. Here's my green. My green is the altitude. The altitude is a geometric mean between each piece of the hypotenuse. So 2 and 12. That is 24. 24 we know is 6 times 4, which is 2 times 2. And this comes out as a 2 root 6. So 2 root 6 is my answer for the y value, and the y value was the value for the altitude. Turning now to the last piece of it, we have another leg. So z is a leg, and z is the geometric mean between the piece of the hypotenuse closest to the z and the entire hypotenuse. 12 times 14 gives me 168, and I broke that up into 2 times 84, and then I'll go down here. Then I had 2 times 42, and that gave me 2 times 2. 42 is 6 times 7, so that's 3 times 2 times 7. Okay, so I have 2's come out as a single, and then I have 42 left inside because I have nothing else to pull out as a pair. So this is 2 root 42, and that ends that problem. Okay, so we're going to continue with this. So sometimes they'll ask you for geometric means, and they're not tied to a triangle. So, for example, my turn. If they ask you, what is the geometric mean of 9 and 4? So set your fractions up just like you would normally. They're looking for the geometric mean, put an x there. The other values are 9 and 4. Do your cross products, and you get x squared equals 36. So x equals 6. So therefore, the geometric mean is 6. And so remember from early on, from our definition, the geometric mean is kind of an average. It's not an average like we're used to taking. It's an average that ties back into square roots. So it's the average, kind of the average of 9 and 4. Okay, so 6 is the geometric average of 9 and 4. Okay, so your turn is next. The question is, what is the geometric mean of 2 and 32? So try that on your own, and then turn off the video and then come back, and I'll go through it with you. Okay, so since I'm looking for a geometric mean, I put x in the spot where the geometric mean will go. My other two numbers go here and here, and they are in the extremes position. So by the way, so you have means positions, which are right here and here, and then you have extremes positions, which is here and here. So 2 times 32 gives me 64. Take the square root, and it's 8, and therefore the geometric mean of 2 and 32 is 8. So it's a number in between 2 and 32. Just like in the previous problem, 6 was a number in between 9 and 4. Okay, so if you think about that, you have some limits. The geometric mean for the second problem can't be less than 2, and it can't be greater than 32. Okay, let's go on to the next page. Okay, so your turn again. So what is the geometric mean of 6 and 100? Again, try it on your own first, and then come back and check the video. So the geometric mean, I can attain that by putting in 6 and 100 in the extreme positions, and x's are in the mean positions. So 6 times 100 is 600, so I need the square root of 600. So to do that, I said 6 times 10 times 10, and I got 10 root 6. So 10 root 6, therefore, is the geometric mean. Okay, because x equaled 10 root 6, and that's what I was looking for. Okay, now all on your own. They've asked you what is the geometric mean of 3 and 4, and I have not given you any fractions to plug in. So you have to come up with them yourselves. So do your problem first and then check back on the video. Okay, so you should have put the x, which is what's missing, in the mean spot, and the 3 and the 4 in the extremes spot. So 12 equals x squared, so x equals radical 12. I know that radical 12 is 2 times 2, which is 4, times 3. Therefore, that simplifies to 2 root 3, and that is my geometric mean. Okay, this next one's a challenge one. So let's read this together, and then I'm going to let you do it, and then you can come back and check the video. Okay, it says 10 is the geometric mean of 20 and what other number? Try to set this up and then solve. So go ahead, stop the video, and go ahead and set that up. So this time they gave you the geometric mean. So I'm going to put the 10 in the spots where the geometric means go. And then the extremes are going to be the 20 and the missing number. So 10 times 10 has to equal 20x. So 100 equals 20x. Divide by 20, divide by 20, and you get x equals 5. And that is your final answer. So you should have a much better handle on this material now.